Hi, so for today we are going to talk about real number systems, integer exponents, and polynomial expressions and operations. So this is my first video about the interventions for calculus. So if you are ever taking this subject, okay, this is a bridging subject for calculus, this video is for you. Especially if you are taking up in your early years of your engineering course. So let's get started. So, real numbers, we're going to talk about different classifying real number. So, we have what we call the natural numbers, the numbers that we used for counting or enumerating items, such as 1, 2, 3, 4, 5, and so on. So, these are considered as natural numbers. Natural numbers are also, of course, called the counting numbers. Okay? So the set of the whole numbers is the set of the natural numbers plus the zero. So including the zero, okay? So this is the set of whole numbers, the set of natural numbers plus the number zero. So we can never have a negative counting natural number. Okay? It's from zero to the positive numbers for the natural numbers. The second type, we have the integers. The integers are the set of integers that adds the opposite of the natural numbers to the set of the whole numbers. So integers also involves, okay, three subsets wherein we have the negative values in the left side of our number line, as well as the zero, and as well as the positive values or the positive integer. So if you remember our number line, okay, if this is zero, on the right side we have the positive values and so on, and on the left side we have the negative values. Okay, so these are integers. And we have rational numbers. A rational number is written as m all over n, where m and n are integers, and n should not be equal to 0. So n should not be equal to 0 because if we have m and n all over n rational number, okay, such as 1/2, 3/4, right? And if the n should not equal to 0, as this will result to an undefined. Okay, so except n equals 0. So because they are fraction, any rational number can also be expressed as terminating and repeating decimal. So we can convert again fractions to decimals and decimals to fraction. So any rational number can be represented as either a terminating decimal, so which one of the example is 15 all over 8. Terminating meaning, okay, if you try to divide it and get the division of it, you will come up with a terminating decimal values. And a repeating decimal is one in which it keeps on repeating, okay, as you try to divide it. Okay? So that is the rational numbers. How about for the irrational numbers? These are numbers that cannot be expressed as a fraction of two integers. It is impossible to describe this set of numbers by a single rule except to say that a number is irrational if it is not rational. Example of which is the pi. We have a value 3.1416 for the first digit, and it is non-repeating, non-terminating. Okay, so we call it irrational numbers. All right, so the set of numbers are this, just the summary. Okay, and we now go to performing calculations using the order of operations. So when we multiply a number by itself, we raise it, or we square it, or raise it to a power of 2. For example, we have 4 squared, we have 4 times 4 equals 16. So we can raise any number to any power, okay? Such as written in this, a raised to n, where a represents the base and n represents the power or exponent of our given, okay? So the exponential notation a raised to n means that a number or a variable a is used as a factor n times. So it means that whatever the value of a, it is constantly, okay, repeated to multiply to itself by how many values of n. So for example, if I have a raised to cube, that only means that that is a multiplied by a itself and multiplied by a itself for 3 times. Okay? So if I have 2 raised to 3, that would be 2 raised to 2 raised to 2, or 2 times 2 times 2 times 2, and that would be 8. Okay? In this notation, a sub n is read as the nth power of a, or to the n, where n is called the base, and okay, where a is called the base, this should be a, and n is called again the exponent. So these are the order of operations. So operations in mathematical expressions must be evaluated in a systematic order, which can be simplified using the acronym the PEMDAS, which means parentheses, exponents, multiplication, division, and last are the addition and subtraction. Okay? So, how to given, okay, or given a mathematical expression, simplify it using the order of operation. Okay? So, for example, this one, for letter A, what we are after is first the parenthesis, okay, itself. So, we need to simplify that first. 3 times 2, that must be 6 squared, minus 4 times 6 plus 2, that is 8. Okay? And next thing that we're going to do, we're going to square 6. That would be 36 minus 4 times 8 would be 36 minus 32. Okay? That would be 4. Okay? So you're going to multiply first because multiplication comes before subtraction in the PEMDAS. Okay, so for letter B, simplifying, we have 5 squared minus 4 all over 7 minus square root of 11 minus 2. So the very first thing that we do, we square 5. That's important. Okay, we have 25 minus 4 all over 7 minus 11 minus square root of 11 minus 2. That would be 9. So now you have 25 minus 4, that is 21 all over 7 minus 3. You divide first. So basically, okay, what you have here, 21 all over 7 is 3 minus 3, that becomes 0. Okay? Alright. So for letter C, we have for letter C, 6 minus the absolute value of 5 minus 8 plus 3 times 4 minus 1. So first we have to evaluate the absolute value. We have 5 minus 8, that is negative 3, plus 3 times 4 minus 1 with the parenthesis, we have 3. So this negative 3 enclosed by the absolute value, we're going to get the positive value of that. That becomes 3. Because anything that is inside the absolute value, we evaluate the positive. Okay, so you have plus 3 times 3. Okay, so very basic. So you have 6 minus 3 plus 9. Okay, already. So you have 6 minus 3. Okay, that would be 3 plus 9. That would be 12. Okay, so for letter C. For letter D, we have, okay, order of operation, 14 minus 3 times 2, that's 6. All over 2 times 5, that's 10. We first multiply before we subtract or even divide. So we have 10 minus 3 squared is 9. So 14 minus 6 is 8. All over 1, that is 8. Simply 8. And the last number is dedicated for you to solve it. Okay? So here are the properties of real numbers. So you have the commutative property for addition, and you also have commutative property for the multiplication. So for the commutative property, it's very useful because it states that whenever we have a plus b, we can interchange the position, okay, without, okay, interchanging the position won't harm or won't change the result. So you have a plus b equals still b plus a. So whichever comes first, it's the same. So same with the multiplication, a times b will be equal to b times a, regardless of their arrangement of whether a is the first or b is the first. Now we have associative property of addition. It states that we have A plus the quantity of B plus C equals the quantity of A plus B plus C. So it doesn't matter if we group these variables into B and C first, that will still be equal to A plus B plus C. The same with the multiplication. If we just group A multiplied by the quantity of B and C, that will still be the same as A, quantity AB multiplied by C. Alright, that's the associative property. How about for the distributive property? We have distributive property for A, okay, multiplied by the quantity of B plus C. So the distributive implies that we should distribute A and C here. Okay, so we have A times B plus A times C. Okay, so that's distributive. So we should distribute the value of A to the addition of this B plus C. Okay, we also have what we call the identity property, of which if we have any variable, okay, plus 0 will still be equal to that variable. And in terms of multiplication, any variable multiplied by 1 is still that variable A. For inverse property, okay, if we have A and we add it to the negative of that A, that simply means A plus the negative of A, positive times negative, that becomes A minus A equals 0. Okay, so for inverse property, we multiply A by its inverse or the reciprocal. The result will be 1. Okay, that's the inverse property, and these are the properties that are basic to real numbers. Okay, so let's go now to an algebraic expression. In the expression x plus 5, for example, we have x plus 5. 5 is called the constant. The constant in the concept of mathematics, the value is not changing. It's constant because it does not vary. And x is called a variable because it varies. Okay, so the variable varies from the word itself, variable. Okay, it can have a value, any value. It can take any value. Let's say negative 1, 2, 3, 4, 5, negative 1,000, even 0. Okay, it can take the value of that because it is a variable. Now, we have an algebraic expression, and this algebraic expression is a collection of constants and variables joined together by the algebraic operations such as plus, minus, multiplication, and even addition. Okay? So any variable in an algebraic expression may take on or be assigned a different values. When that happens, the value of the algebraic expression changes. So of course, since the algebraic expression contains variable, if we assign a value in that specific variable, let's say x equals 1, we can get a result. And that result will be different when we assign different value of x. Such as, first we assign 1, and if we assign negative 1, the value of the algebraic expression may change. Okay, because we change the value of the variable. So list the constants and variables for each algebraic expression. We have x plus 5. We know that the variable is x and the constant is 5. For 4/3 pi r cubed, we know the constants are 4/3 and pi, of course, that's still a constant. And the variable is the r. Okay? So in the value of letter C, so we have square root of 2m cubed n squared. So the constant is 2. The variables are m and n. Okay? So these are the variables and the constants in our expression. So, if we are going to evaluate an algebraic expression, we simply take the value of the given x and try to substitute it to the given expression. In this case, we are given 2x minus 7 for our expression, and we are going to evaluate the value of this expression for different given values of x. So let us try. So we have 2x minus 7 At x equals 0, we just simply replace x with 0. That's what makes a variable variable. It can take any assigned value of x. So you have 2 times 0 minus 7. Obviously, this would be 0. So the answer is negative 7 for letter A. For letter B, we have 2 times 1 minus 7. Okay, that would be 2 minus 7. That would be negative 5. For example, we have x equals 1 half. We have 2 raised to 1 half, or 2 minus 1 half, or 2 times 1 half minus 7. 2 times 1 half, the denominators will cancel. So you have 1 minus 7. So this must be negative 6. And x equals negative 4. So you have 2 times negative 4 minus 7. So negative 4 times 2, that would be negative 8 minus 7. Negatively, we can add this. Negative 8 minus 7. They will add negatively, okay, negative 15. So as you can see, for different values of x, we have a different values of the algebraic expressions. Okay? So I leave this with you for your activity. Okay? You can do this for your proper practice for this video. Okay? So let's go now to an equation. An equation is a mathematical statement indicating that two expressions are equal. And this is preceded by, we have the left side of the equation equals the right side of the equation. Left-hand side and the right-hand side, it expresses equality both on the left side and on the right side. So meaning, what's on the left equals what's on the right. These expressions can be numerical or algebraic. Algebraic meaning it can have constants and variables involved. Okay? And the value that makes the equation true, okay, are called solutions. Okay? So the value of x that makes, for example, a variable x that makes the solution true equals, okay, our found solution, our code solution, and are found using the properties of real numbers and other results. On the other hand, a formula is an equation expressing relationship between constant and variable quantities. Such equations we have seen: F equals ma, we have the volume of the sphere, we have 4/3 pi r cubed. So you can see we have the area of the square, area of the rectangle, length times width. Okay? So basically, these are all formulas that represent a relationship between the constant and the variable quantities, okay, given in the problem. So let's try to solve this. A right circular cylinder with radius r and height h has the surface area of S in square units, given by the formula S 2 pi r multiplied by r plus h. Okay? Find the surface area of a cylinder with a radius 6 inches and height 9 inches. Leave the answer in terms of pi. So it's pretty forward because we are already given with the radius that is 6 inches and you already have height of 9 inches. So the surface area will be 2 pi. The r or the radius is 6. Then you have 6 plus 9. So you have 2 times 6, that would be 12 pi. And then you have 6 plus 9, that would be 15. So 15 times 12, I believe that's 180. Okay, 2 times 1, we have 3, 5, 1. So 0, 8, 1. So 180 pi is the surface area. Or if you want to include the units, of course, that would be 180 pi square inches. That's the surface area of this right circular cylinder. So that's how are you going to use formulas. The formulas are there, already derived. And what are you going to do? Sometimes you have to find the unknown parameters. But here, in this simple given problem, we already have the missing parameters or the missing variables. We already have the value for the variables, the R and H. Okay? So, how do we simplify algebraic expressions? Sometimes we can simplify an algebraic expression to make it easier to evaluate or to use in some other ways. Okay? So, simplify each algebraic expression. So, the very first thing in simplifying algebraic expression is to combine like terms, meaning you're going to combine the constants for the constant, and you're going to combine x with the x's, y with the y's if there are 2 or 3 variables, and of course, if you have what? If you have operations to perform, you have to combine like terms. And if you have minus or subtraction, you have to distribute the minus sign or the negative one on the parentheses, such as letter C. So you have minus 4 here, so you have to distribute here. Okay, so for letter A, how do we solve this? You have 3x minus 2y plus x minus 3y minus 7. I'm going to group them first with x's, so you have 3x plus x, and then I have negative 2y minus 3y minus 7. That's commutative property. We just interchange the position. Okay? So you have 3x plus x, that would be 4x, minus 2y minus 3y, they are like terms as well as the x's. So negative 2y minus 3y, we add them negatively. Okay? And then we have negative 7 here. So nothing to simplify for the constant. So this is our answer for letter A. For letter B, we have 2r minus 5 multiplied by 3 minus r plus 4. Obviously, this negative 5 should be distributed. So you now have 2r, negative 5 times 3, that's negative 15. Negative 5 times negative r, negative times negative, that becomes positive. You have 5r plus 4. So you now have, combining like terms, you have 2r plus 5r minus 15 plus 4. Simplifying 2r plus 5r, that's 7r. Okay? And then, you have what? Negative 15 plus 4, that would be negative, okay, plus negative 11, or simply 7r minus 11. Okay, so that will be our answer. For letter C, obviously, we have to, okay, we have 4t minus 5 all over 4s, then minus 2/3 t plus 2s. So distribute the negative sign, distributive. So you have 4t minus 5 all over 4s. Then you have negative 2/3 t. Okay, negative 2/3 t. And then you have minus 2s. So combining like terms, I have 4t minus 2/3 of t. Then I have minus 5/4 of s minus 2s. Okay? So if I do that, I just simply 4 minus 2/3. So I just have to cross this. So I have 12. 4 times 3 is 12 minus 2. Okay? Because of this 2. T all over 3. Copy the same denominator, and the same thing that goes here. So if I rearrange this, we have negative 2s minus 5 all over 4s. Okay, I would do the same thing. So negative 12, okay, 12 minus 2, I mean. So you have 10 all over 3 plus t. 12 minus 2 is 10 all over 3 plus t. So in this, same process that we are going to do, we have 4, okay, we have 4 times, we have negative 2 here. So 4 times negative 2, we have negative 8 minus 5, okay, negative 8 minus 5 of s all over the 4. So you have 10 all over 3t, okay, minus 13 all over 4s. Alright, so that's your answer, 10 all over 3t minus 14 or minus 13 all over 4s. So we just use Okay, how to multiply or how to subtract, okay, a whole number and a fraction. We combine like terms and we perform the indicated operation. For letter D, we have 2mn minus 5m plus 3mn plus n. Simply combine like terms. So you have 2mn plus 3mn minus 5m plus n. So you have 2mn plus 3mn, that's 5mn. Then you have minus 5m plus n. Okay, so the n and m doesn't have any like terms within the algebraic expression. So let's go now to exponents. The product rule for exponents. So we have several rules for exponents. Okay, for any real number and a natural numbers m and n, the product of or the product rule of the exponent states that if we have the same base a and we have a certain power to which these bases are raised, let's say m and n, you are going to add their exponents if they are multiplied. So for example, if you have x times x, that would be x raised to 1. It's understood that when there is no exponent, it is raised to 1. Plus, we have x raised to 1. So they have the same base. These are the base, which is x. And they have m and n as the value. Okay? So what we really do is simply use the formula a raised to m plus n. So you have to copy the base, which is the x. And then you have m plus n, 1 plus 1, so you have x squared. So that's why x times x would be x squared. So another thing, if we have x squared multiplied by x cubed, that would be x raised to 2 plus 3 equals x raised to 5. So that's the product rule. So let's try it here. Example, we have t cubed multiplied by t raised to 5. Of course, they have the same base, t. So you have to add the exponents if they are multiplied. So you have t raised to 8 as our answer. For letter B, we have negative 3 raised to 5 times negative 3. We all know that this negative 3 has an exponent of 1. So you have negative 3, 5 plus 1, we have negative 3 raised to 6. Okay, for letter C, we have x squared multiplied by x raised to 5 multiplied by x cubed. So if we do that, we have x raised to 2 plus 5 plus 3. So that would be x raised to 10. Okay? So simply add the exponents when they have the same base, okay, and if they are multiplied together. So multiplication means adding the exponent. So remember that. Multiplication means adding exponents. So if we have the product rule, we also have the quotient rule. The quotient rule allows us to simplify an expression that divides the two numbers with the same base but different exponents. So whenever we have a division of the same base with exponents m and n, we simply minus their exponents. So take a look at this example. We have x squared all over x. Okay? So the value of exponent here of x is 1. Obviously, even if we don't write. So that would be what? X raised to 2 minus 1, which will be x. So that sometimes we just cancel this out, and we have a value of x for the simplification of this. And that is because of the quotient rule of the exponent. And why do you think y all over y equals 1? That is still because of the quotient rule of the exponential rule. So we have y raised to 1 minus 1, which means y raised to 0, and any number raised to 0 or any variable raised to 0 will be equal to 1. So that's why we just simply sometimes cancel it and labeled it as equals to 1. So let's try. For letter A, we have y raised to 9 all over y raised to 5. That would be y raised to 9 minus 5. And that would be y raised to 4. Okay? So for letter B, we have t23 all over t raised to 15. Same base, multiplied or divided. So you have t23 minus 15. So that you have what? T raised to 8. 23 minus 15 is 8. Okay? So for letter C, we have z square root of 2 quantity raised to 5. Then on the denominator, you have z square root of 2. So obviously, we know that the exponent of that is 1. So that would be z square root of 2, meaning 5 minus 1. And that would be z square root of 2 raised to 4. Right? Okay. So using the power rule of exponents. Okay? So for the power of rule of exponents, okay, if a certain exponent is raised to another exponent, what we are doing is simply what? Multiplying itself 3 times. Okay? So that's why if we have x squared raised to cube, what we do is just simply multiply 3x squared here. X squared times x squared, that is x raised to 4. And x raised to 4 times x squared, their exponents will add, therefore giving a total of x raised to 6. But whenever we see x squared raised to 3, we just simply multiply 3 and 2. And that will be our result. Okay, that's the difference of the power rule and the product rule of exponents. Okay, so the power rule of exponents suggests that for any real number a and positive integers m and n, the power rule exponent states that we have a raised to m, okay, quantity a raised to m raised to n, we multiply the exponent m and n given that they have the same base. Okay, so for example, for letter A, we have x squared quantity raised to 7. Okay, so this x squared is raised to a higher exponent, which is 7. So what are we going to do? We are just simply multiplying 2 and 7. So you have x raised to 2 times 7. That would be x raised to 14. Okay, for letter B, we have 2t raised to 5 cube. Okay, so let us remember that if we have constant, one properties of exponents is that this 3 will be distributed to both the 2 and the t. So you now have 2 cube, okay, because 3 times 1, the exponent of 2 here is 1. Then you have t raised to 5 times 3. Okay, so we have 2 cube, which is 8. And then we have t raised to 5 times 3, that would be 15. So this would be your answer. Okay, so this 3 will be distributed, again, to both 2 and to both the variable t. So for letter C, we have what? We have negative 3, okay, raised to 5, raised to 11. So obviously that would be negative 3, 5 times 11. So that would be negative 3 raised to 55. Okay? So just multiply. That's the power rule for exponents. So the product rule is different from the power rule. In product rule, if we have products of two exponents, we just simply add the exponents. Okay? In the power rule, meaning our exponent is again raised to another exponent, we just simply multiply the exponents. So that's the difference between the product rule and the power rule. Okay? And the two are different from each other. Okay? So the zero exponent rule. So for any real number a, the zero exponent rule of exponent states that any variable or any number raised to 0 will be equal to 1. So meaning we have x raised to 0 equals 1, y raised to 0 equals 1, z raised to 0 equals 1. Okay? And if we have 2 raised to 0, that will still be equal to 1. 3 raised to 0, that will be still equal to 1. Okay, so example, we have c cube all over c cube. So we say that this is 1, but how can we prove it? So you have c raised to 3 minus 3 because of the quotient. That will be c raised to 0, and that would be any number raised to 0 would be 1. Okay? Alright, so for letter B, we still have, negative 3x raised to 5 all over x raised to 5. So I can factor out first negative 3 here, and we have x raised to 5 all over x raised to 5 here. Okay, so you have negative 3, then x raised to 5 minus 5. Okay, so you have negative 3 times x raised to what? 0. 5 minus 5. X raised to 0 is 1. So you have to multiply negative 3 by 1. So the answer would be negative 3. Okay? So for letter C, we have j squared k raised to 4 all over j squared k multiplied by j squared k raised to 3. Okay? So this is simply j squared k raised to 4. And obviously, we can use product rule here. J squared k, this is raised to 1, and j squared k raised to 3. So that becomes j squared k raised to 4 if we multiply these two. And after all, we know that this will be cancelled by properties of exponent. That will lead us to exponent of j squared k raised to 0, and that raised to 0 would still be 1. Okay, and I hope that is clear for the zero exponent rule. So how about for the negative rule of exponent? So for the negative rule of the exponent simply states that for any non-zero real numbers, a and natural number n, the negative rule of exponent states that a raised to negative n will be equal to 1 all over a raised to n. So we can get, again, we can eliminate the negative, okay, of this exponent if we just going to get the reciprocal and negate its exponent. So for example, we have y raised to negative 3. That is equivalent to y raised to cube. Okay, y raised to 1 all over y raised to cube. So what we are doing here is we are negating the exponent whenever we get, okay, the reciprocal. So for example, I have x squared, and that is still equivalent to 1 all over x raised to negative 2. So I'm negating the exponent. Okay? So if I have negative, so we have y, again, raised to negative 10. That is equivalent to 1 all over y raised to the negative of negative 10. And negative of negative 10 is simply y all over y raised to 10. Okay. For example, for letter A, we have z squared multiplied by z all over z raised to 4. So z squared multiplied by z is z cubed all over z raised to 4. And that would be z raised to 3 minus 4. Z raised to 3 minus 4 is z raised to negative 1. To eliminate that, we can get the reciprocal 1 all over z raised to the negative of negative 1. And the negative of negative 1 is 1 raised to z, positive 1, or simply 1 all over z. The negative of negative 1 when multiplied here becomes positive. For letter B, we have theta raised to 3 all over theta raised to 10. So you have theta raised to 3 minus 10. Then you have theta raised to negative 7. If we negate that, we have 1 all over theta raised to the negative of 7. Negative of negative 7, that would be 1 all over theta raised to 7. Okay? So for letter C, it's the same. We have negative 5t cubed raised to 4 all over negative 5t cubed raised to 8. So that would be still the same. Negative 5t cubed raised to 4 minus 8. That would be negative 5t cubed raised to negative 4. So to eliminate the negative 4, we have 1 all over negative 5t cubed raised to 4. Alright? So that will be the negative rule of exponent. So that's very easy. If you wish to eliminate the negative value or the negative exponent, you just have to simply get the reciprocal and put a negative, negate the exponent, so that the negative of negative becomes positive. So the power of a product rule of exponents. For any real numbers a and b and any integer n, the power of a product rule of exponents states that ab raised to n equals a raised to n b raised to n. So I think this will be our last topic. Okay, so I will be cutting the video and creating a video about polynomial on the next video. So I'm just going to finish the product rule and the quotient rule and solve some or for the examples, for your examples here to work with. Okay, so we can simplify or we can distribute the n for first the a and the b. So let us try to solve an example. We have ab squared raised to cube. So this 3 will be distributed. You have a raised to 3 times 1 and you have b raised to 3 times 2. So you have a cube and then b raised to 6. So you multiply because this is raised to a certain power. So for letter b, we have 2t raised to cube. So you have 2 raised to 3 times 1 and then t raised to 1 times 3 or 3 times 1. So that would be 2 cube t cube, or that would be 8t cube. Okay? Because 2 cube is 2 times 2 times 4. Okay, 2 times 2 is 4 times 2 is 8. Okay? So for letter C, we have negative 2w cube. So you have negative 2 cube. Okay, you have w cube times cube. Okay? So that would be negative 8. Okay, negative 2 times negative 2 is positive 4 times negative 2 is negative 8. So if we have an odd exponent, negatively we have an odd exponent and we are going to raise it to an odd exponent, okay, the result will always be negative. And if it is in even, let's say raised to 4, negative 2 raised to 4, the result will always be positive. Okay? So we have w 3 times 3, that would be raised to 9. Last, for letter D, second to the last, we have 1 all over negative 7 z raised to 4. Okay? So I think that's a typographical error because of course we can still solve, I think. So you have 1 all over negative 7 raised to 4 and then we have z raised to 4. Okay, so 7 times 7 is 49. 49 times 7, that's 63. 6, 7, 14, 21, 28. Plus 6, that's 34. And another 7 because I have 2 and I have 3. So 3, 4, 3 times 7, that would be 21, 28, 30. You have 21, 24. So do you have 1 all over negative or positive because it's raised to even number 2401 z raised to 4. And lastly, for letter E, you have e raised to negative 2 f squared raised to 7. So distribute, so you have e raised to negative 2 times 7 and f squared times 7. So you have e raised to negative 14 and you have f raised to 14. So again, we can eliminate e raised to negative 14 by getting the reciprocal. So you have 1 all over e raised to 14 multiplied by f raised to 14. And this is numerator times numerator, denominator times denominator. So that would be f raised to 14 all over e raised to 14. So that will be our final answer for this. That is the power of a product rule of exponents. We just simply distribute the power on each of the variables. Okay? So, last we have also the quotient rule, the power of a quotient rule. So if we can distribute it, okay, in the product rule, we also can distribute it in exponent or quotient rule. So we have quantity A all over B raised to n would be equal to A raised to n all over B raised to n. So for example, you have 4 all over Z 11 cube. So this will be distributed both to the numerator and to the denominator. So you have 4 cube all over Z 11 times 3. So you have 4 cube, 4 times 4 is 16 times 4 is 64 all over Z all over Z raised to 33. So that's how you get the power of a quotient rule of exponent. So for letter B, we have P all over Q cube raised to 6. So you have P raised to 6 all over Q 3 times 6. So that would be P raised to 6 all over 3 times 6 is 18. P raised to 6 all over Q raised to 18. So for letter C, we have J cubed K raised to negative 2 raised to 8. So if you distribute that, we have J cubed multiplied by 8 multiplied by K raised to negative 2 times 8. So you have J 24, then you have K negative 16, and we wish to get the reciprocal of this. So this will become 1 all over K raised to 16. And simplifying, you have J raised to 24 all over K raised to 16. Okay, so as much as possible in the final answer, we don't want any negative exponents. So that's why we use the rule of the negative exponents to eliminate the negative exponent in the final answer of our choice. Alright? And this is left for you in the assignment. Okay? You can do it. I believe in you. So you just have to practice yourself with this. Okay? For the next video, we are going to talk about polynomials. So I hope that's all. Okay? I hope you learned something from this video. If you like this video and if you learned something from this video, please do subscribe to my channel and hit the thumbs up and comment down below your answers for these expressions. Okay? So I'll be waiting for your answers and see you on the next video about the polynomials and operations in polynomials. Again, this is Engineer Abat. See you again when I see you on the next video. Bye.